let's do interesting question. Similar to the previous one, we are going to use same theorem, but no triangle in this case, only circles, two circles, right? Let's read the question first. AB and CD are common tangents to circle which touch each other at D. Okay, so you can see that there are many tangents, I think, right? You can see, and D is the point where two circles touch each other. Okay, if AB is equal to 8 centimeters, so length of AB is given 8 centimeter, then find the length of CD. We need to find the length of CD. Let's write first of all what's given over here, that AB is equal to 8 centimeter, and we need to find value of CD. How shall we do that? No diameter is given, no radius is given, and I think we don't even need that one. Without that, we need to find it. So just tangents and we will be able to solve this sum. Remember, we are going to use the same theorem that we used in previous case, that tangents from the external point to the circles are equal in length, right? Let's write first of all tangents from external point to this circle are equal in lengths. Simple, done. Mention this statement every time when you use this concept because it's necessary. We need to write the theorem, right? So first of all, let's talk about the external point. There are many. Which external point we shall start from? Rather than talking about external point, we need to talk about circle. First of all, let's talk about this circle, this ACD where it touches, right? So I'm taking external point C over here. So let's see external point C. For that, tangents, which are the tangents coming out from the point C, which is AC and CD. So this and this will be equal. So I can write that CA is equal to CD. Done. Now let's write for another circle. External point will be same, which is C over here. So let's write external point C, right? Here it will be CB is equal to CD. So CB is equal to CD. Now see these two relations. Let me write over here so we can understand properly that CA is equal to CD. Now it's given in the manner that both of these sides CB and CA are equal to CD. So can I write conclusion? Very important conclusion we need to write, that CA is equal to CB. So can I say that C is the midpoint of AB, right? That's the conclusion. C is the midpoint of AB. Done, right? So if I want to find the length of CA and CB, how shall I get it? Divide by 2. We have value of AB. So if I want CA or if I want CB, all I need to do is divide the total length by 2, that is 8 by 2. So CA is equal to CB is equal to what? 4 centimeter, right? We don't want to find CA and CB though. We want to find CD. Now see, we have relation here that CA is equal to CD and CB is equal to CD. So what is the length of CD? Let's use that over here. So we'll get the final answer. That's very simple, that we can write CA is equal to CD. So CA value is 4 is equal to CD. So CD is equal to 4 centimeter. That's my answer. Simple, right? Let's recall this step. Here we are not having triangle, but here we are having two circles that they touch each other at point D. Then C is the external point. These two tangents are equal. CA is equal to CD. Then from this circle, CB is equal to CD. So you can see that CD is coming two times, means CB is equal to CA. C is the midpoint of AB. So if you want the length of AC or CB, divide by 2 the length of AB, and you will be getting the value of any of it, CA or CB, and that is equal to CD. This question generally comes for 1 or 2 marks. If it is for 1 mark, then if it is MCQ, then you just need to do the rough calculations, then you can get the answer quickly. If you need to show the calculations, you need to show the calculations. So far we discussed questions related to circles and triangles, right? Now we are going to discuss questions regarding to quadrilaterals and circles. Let's read the question first and solve it. A quadrilateral ABCD is drawn to circumscribe a circle. Okay, so there is a one quadrilateral ABCD and circle which touches each side of the quadrilateral, right? Prove that AB plus CD. So AB plus CD is equal to AD plus BC, right? So sum of these two sides is equal to sum of these two sides. How to proceed? Remember, whenever we deal with circles and whenever we are having triangles or quadrilaterals, start with the tangents. That's the best way to do it because that's the only theorem we know so far, right? So let's start. I told you in that case, if you want to use the theorems related to tangent, equal tangents, you should be counting external points. How many external points are there? First of all, this A, then B, then C and D. So there are 4 external points are there, right? And you can see the way I use the colors, it is easy to observe that AP is equal to AS, then BQ is equal to BP, then CQ is equal to CR and DR is equal to DS. We know that, very simple, right? But how to prove this one? AB plus CD is equal to AD plus BC. Okay, so before we find this one, let's write first of all 4 sides. Why? Now let's write first of all AB. Why am I talking about this? AB, can I write can I express as a sum of 2 different sides or part of it, which is like PB, BP, okay, plus AP, right? Can I write this same for the side BC? Let's write for BC. BC is equal to BQ, or let's say BC we are talking about CS, so BQ, right, plus this one which is CQ. Okay, done. Now let's write for the third side which is CD. So CD can be written as this one first of all, CR, okay, plus DR. So DR here, done. And the last side which is we need to prove AD. So AD is equal to, AD is here, okay, so AS, right, AS plus here DS, DS, done. Why have I written this? We'll come to know why. Now let's start with the tangent of the circle. So how shall we proceed with the tangents? So tangent, we know very well that what's the theorem that we are going to use? Tangents from the external point. Let's write tangents from external point to the circle are of equal length. Are of equal length. Done. Theorem is written. Now let's talk about the 4 points, right? Let's talk about the 4 points. Now which are the 4 external points? We have 4 external points A, B, C, D. So let's start with the 4 external points. First of all, external point A. External point A, right? From A there are 2 tangents coming out, which is AP and AS. So AP, okay, AP is equal to AS. Done for the first external point. Let's talk about the second external point. So external point B, right? External point B. For that it will be BP, okay, BP is equal to BQ, right, is equal to BQ. For external point C, let's write for external point C, external point C. Done. Now for C, how can we write? Very simple, right? You need to start from C, it will go to Q and then R. So CQ is equal to CR. Okay, so CQ is equal to CR. Now what's left last, which is external point? D. So let's write external point D. External point D. How can I write? DR? Yes. Here we had CQ, so it's okay. Let's write DR. Okay. DR is equal to, what are we going to write? DS. DR is equal to DS. Simple. Now what I'm going to do, I need to get sum. So I need to add this. Okay, let's start adding. First of all, AP and BP. I'm going to start with this one, AP and BP. So let's start AP plus BP. What will come on RHS side? That is AS and BQ. So AS plus BQ. Then CQ and DR. So we need to take CQ and DR. So rather than, let's take that, instead of CQ, let's take CR. Okay, here we are going to write alternate, which is CR is equal to CQ. I'll tell you the reason behind that. Take this same alphabet with you. That is really easy. So CR plus DR. Here CR plus DR. So on RHS there will be CQ and DS. So here CQ plus DS. Now why we have written these four equations? Important. AP plus BP. AP plus BP. How will I replace with? AB. So that will be your AB. Done. Then CR and DR. CR and DR, which is CD. So this part I will be replacing with CD. Then AS and BQ. AS and BQ doesn't make any sense, but AS and DS make sense, right? See, AS over here, DS over here. So where is AS and DS will make what? AB. Will rearrange it, don't worry, you can rearrange always. And BQ and CQ. So this BQ and CQ will make what? You can see in figure as well, it is BC, right? So let's first of all write as it is after arrangement, then we'll finally write it because our sum is almost done. So here AP as it is plus BP plus CR plus DR is equal to AS. Shift this DS with that. Okay, DS plus BQ plus CQ. Done. Now let's replace them. So first there will be what? AP and BP. You can think AP and BP. That will be your AB. Then CR and DR. CR and DR. That is what? CD. Okay. Then AS and DS. AS and DS will give you what? AS and DS will give you AD, right? So AD here plus BQ and CQ. BQ and CQ. Very simple it is. What? BC. See, this is what we need to prove, right? So we are done with this sum. Very simple. Let's recall. You were thinking that why have I written this? This is the reason I have written, and at the end we can substitute. AB is equal to BP plus AP in the same manner, right, for all the four sides. Very simple, we know that. Then use the theorem of this chapter, which is tangent theorem, that tangents are equal from the external point to the circle, right? So I use that one for 4 external points. I told you count the external points, it will be very easy to identify, right? This is confusing because it's look like a square or quadrilateral only, but remember this point will help you to get this 4 possibilities. Afterwards add them. Why have I added them? Because in the answer we need addition, right? So I have added it. First add this 2, add in a manner that you get one side. How did I think of it? AP and BP. I know if I add them AP and BP, I will be getting AB. So add systematically. Don't add randomly, you won't be able to get the answer, right? So AP plus BP will give you AB, right? Same here, you can think of CR and DR. CR and DR will give you DC. So BQ and CQ will give you BC, and AS and DS will give you DA. So this is how we prove relation for circle and the quadrilateral. let's do one more question related to circles and quadrilateral. So this is the theorem, or this you can also take a statement as well, not exactly the theorem. Prove that parallelogram circumscribing a circle is rhombus. Okay, so we have parallelogram, okay, parallelogram, and there is a circle circumscribing, means it is touching the parallelogram, right? Each side is a rhombus. We need to prove that it is rhombus. This parallelogram is rhombus if it is circumscribing. First of all, let's give name. Let's start with A, then B, then C, and D. Right? Now let's name these points as well, which touch the parallelogram. PQRS only. Let's give P and Q and R and S. Done. So we have named it. Now how shall we start? First of all, whenever you have something like this, start with what is given, what we need to prove, and finally the proof. So let's start with what is given, right? We have ABCD parallelogram. Yes, most important. ABCD is parallelogram. Done, right? Center with O, circle with center O. Let's take circle with center O, right? Circle with center O. Done. Now we need to prove. What we need to prove? We need to prove that ABCD is rhombus. We need to prove that ABCD is rhombus. So how shall we start? You can think of this question as the previous one only, right? We are going to take 4 external points A, B, C, D, right? We are going to write statement for AB, then CD, then DC, then AD, right? So we are going to repeat the same steps. Let's start. So first of all, let's write for the AB. So AB can be written as AP, right, plus BP. Done? Then let's write another one, which is BC. So BC can be written as, right, let's start BQ, okay, BQ plus CQ and CQ. Done. Now let's write about DC. DC can be written as CR, okay, CR we start with, and another is DR, so DR. Done. And AD can be written as DAS plus DS. Done. So 4 sides are written. Done. Now let's start with the tangents, external points. So external points, there are 4 external points. Remember, there are 4 external points: point A, point B, point C, and point D. So from 4 external points there are tangents, right? And those tangents should be what? Equal. So you can write the theorem, and then let's move on. So from external point A, let's start with external point A. So from external point A, there are 2 tangents, AP and AS. So AP is equal to AS. Done. Let's write for the second tangent, second external point. External point B, that is BP. Okay, here BP is equal to BQ. So that's done, BQ, right? Let's move for the external point C. You can write for all the 4 points. It's very simple. We are repeating, I think, 3rd time. So external point C, that is CQ and CR. So CQ is equal to CR, or you can write as well CR is equal to CQ. Both are equal. But remember, we are going to add here as well. Important. And the last external point, that is point D. So external point D, that is DS is equal to DR. So we had CR, so let's write DR here. So dr is equal to ds. Now what we are going to do, we are going to add this 2 first, then this 2 afterwards. Let's start. So AP plus BP, AP plus BP, this is on the left hand side. What about the right hand side? AS plus BQ. So let's write AS plus BQ. Now about this 2, CR and DR, take the same alphabet RR, it is very helpful. So plus CR plus DR, and here what? CQ and DS. So CQ plus DS. Done? Simple. Now AP and BP we have already done, that's what? AB. Then CR and DR will be DC. Then AS and DS, remember AS and DS will give you AD, and BQ and CQ will give you BC. Let's replace because we need to do more steps as well. So here I will be writing AB plus here what? CR and DR will be DC. Simple. And AS and DS will be AD plus BQ and CQ is DC. Okay. This is up to the last sum. We have done this, right? Very simple. You write 4 sides, you write 4 external points, you add them in a proper manner that you get the sides. Now, we use the conditions for this circle. But what about the condition which is given over here? ABCD is parallelogram. Now, what is the condition for parallelogram? One very simple, we don't need to think much about diagonals, not about even angles, because we are not talking about angles, then don't think about angle properties. Are we talking about diagonals? No. So forget even diagonals. What we are talking about? We are talking about sides of a parallelogram. So what is the property related to parallelogram of sides? Opposite sides are equal. That's the property, right? So if I take ABCD as the parallelogram, opposite side, AB and DC is the opposite side. Okay, one more pair is there, BC and AD or DA. So I can write that AB is equal to DC, right? Let's write ABCD is parallelogram. Done. Now what is the property? AB is equal to DC. AB is equal to DC. Now next is BC is equal to AD. So one more property, BC is equal to AD. Done. Now, how can we use this? Let's substitute this over here. So instead of AB, or let's say instead of DC, I am going to write AB. Let's come to this property which we were discussing. Here it is AB plus, instead of DC, what I will be writing? Again AB. Remember, I am writing again AD. So is equal to AD as it is. Let's keep it as it is, plus instead of BC again I will be writing AD, right? So I can say that AB twice AB is equal to twice AD. This 2 will get cancelled. So AB is equal to AD, right? This is the property. This is the conclusion that we get. AB is equal to AD. Means this side and these 2 sides are equal. Now, one thing we know from this parallelogram, that AB is equal to DC already and AD is equal to BC. So, from this one, see, from this property and from these 2 properties, what can I write? AB is equal to, first of all, what? AB is equal to, first of all, let's write AD. Now, what is related to AD, which is BC? And what is related to AB? That is DC. So AB is equal to BC is equal to CD is equal to AD. Let's arrange in the proper way. So AB is equal to BC is equal to DC is equal to AD. So all 4 sides are equal. All 4 sides are equal. And it is given that this is parallelogram. So if it is parallelogram, and if all 4 sides are equal, then what will it be? Rhombus, right? It cannot be square because we need all angles equal, right? All the 4 angles equal. That is not possible and we are not discussing about that. So I can say that ABCD is rhombus. ABCD is rhombus. Let's repeat one time. So we need to draw this figure. Remember, you can start with the parallelogram and circle, right? What are the given conditions? Circle and the parallelogram. What we need to prove? That this parallelogram is the rhombus. Again, you can start with all the 4 sides in terms of other 2 sides which is given over there for AB, BC, CD and AD. Afterwards, there are 4 external points. 4 external points. So write tangents for them, because tangents from the external point to the circle are of equal lengths. You can write this statement here. Then for the 4 points, then you need to add in the manner that you get one side, then afterwards another, and all the 4 sides in sum like this one, okay, in the addition. Afterwards, we need to use this property that ABCD is the parallelogram. We used a property that this is the circle and tangent, but we need to use another property as well of the parallelogram, which opposite sides are equal. We are not talking about diagonal, not even about angles. So only consider the property of sides. Opposite sides are equal. Now these 2 conditions substitute over here. So you will get AB is equal to AD. Now we need to just match it. If these 2 sides are equal and opposite sides are also equal, so all 4 sides will be equal. So I can say that ABCD is the rhombus.